Hi, everyone. A quick lesson on critical values. In your textbook on page 477, we have a section on critical values. So, first of all, what do we mean when we talk about critical values? Well, let's start with the normal curve here. And we know from earlier lessons, we know that you take your result from your sample, p hat, you add and subtract 2 times your standard error, which, yes, it's PQ over N square root, but I'll just write SE for short for standard error. I don't want to write out the whole thing right now. So once you know your standard error, you know that on average, your sample is off by 1 standard error. So you times by 2 standard errors because we know 95% of samples will be within 2 standard errors of the real percentage, put P right in the middle, the real percentage of your population, whatever that is. Your p hat is 95% likely to be within 2 standard errors of that p right there. So that's the idea. Now, so this would give you 95%. We call it 95% confidence. All right. However, a couple things. First is, it's actually, if you want to get more precise, the 68, 95, 90% rule is just a rough guide. 2 standard errors is not actually exactly 95%. So that's the first issue with this little formula right here. It's not precise. It's just a rough guide. But the second thing is, sometimes you don't always want 95%. What if you want other confidence levels? Like you want to be 99% sure because if you're, you don't want to take a 5% chance of being wrong. So you want to be 99% sure or 99.9% sure. Or sometimes you want to shrink that margin of error down and you're willing to be only 90% sure of being right. So how do you deal with other confidence levels? So this brings up the idea of critical values. All right, so for example, let's say you want to go out 3 standard errors because you want to be 99.7% confidence. So if you did p hat plus or minus 3 times the standard error, well, we know from the 68, 95, 99.7 rule that if you go out, so p is in the middle, if you go out 3 standard errors up and down, then you can say that 99.7% of all samples are within 3 standard errors of the real percentage, whatever that is. And so you take your standard error times by 3. And then you can be 99.7% confident. But usually people don't use 99.7. People like rounded numbers like 95 and 99 and so forth. So let's say you want to be, let's say, 99% confident. All right. So if you want to be 99% confident, how many standard errors is that going to be away from P? So it's not going to be 3. It's going to be 2 point something. You would say that you're 99% sure that your P hat, whatever that is within 2 point something standard errors of the real percentage right there. So where's the cutoff? The answer is the critical z-score or critical value. All right, so let's have a definition here of what is exactly do we mean when we say a critical value. So you can say a critical value or critical z-score is a particular. It's a particular z-score that that produces a desired, or I'll say the desired area under the normal curve. And the reason for that is to get you a desired number of standard errors to multiply by. All right. Now, in our textbook, the symbol they use is a Z with a little asterisk up there. That's a lot of textbooks use that for the symbol for their critical Z. In other textbooks, though, you might see this. You might see Z with the subscript C for critical, right there. And also, I've seen this as well, a Z with the subscript alpha divided by 2. In fact, there's one of the videos that you'll see later. The YouTuber that made that video uses this subscript, which just means critical value. It's kind of a weird way to say critical value, but I'll explain in a few minutes what that alpha over 2 really means. So how do you figure it out? How do you figure out the critical value? For example, let's go back to our 99% confident. So you have to use some kind of tool, some kind of calculator or something that does areas under the curve. And so my favorite tool these days is the, let's go back to, oh, darn it, just a minute. Okay, here it is. The normal curve calculator right here. The link to this is on our Canvas page. And so you can do inverse normal, where you type in the percentage in the pink box, and then it gives you the desired z-score over here. Okay, so first, mean is 0. We're talking about z-score, so mean is just 0. Standard deviation is just 1. And then anytime you're doing a critical value, you want the middle. So let's first draw a picture for 99% confidence. So here's our normal curve. I want to know what is the middle or central 99%. So what is that z-score? Z equals what? So the cutoff right there. What's that z-score that would give you the middle 99%? And then, of course, there's going to be a negative z on the other side. Okay, and so on this website here, just type in 0.99, and then for you don't want greater. We don't want the z. This gives you the top 99%. There's another symbol right here. We want the in between. We want x is in between negative x and positive x. So click that one, the in between one, and then it gives you the answer right there. So it shades in the middle 99%. Oh, somehow it changed to 98. Let's change that to 99. Pardon me. Okay, there we go. So it's shaded in the middle 99%, and then it gives you the critical value that gives you that middle 99%. So it's 2.57583. Usually people just round it to 2.576. Okay, so what that tells you then is, oops, let's click the eraser here. Okay, so 2.576 and negative 2.576. So you can say that on a standard normal curve, the middle 99% of the area under that curve is in between negative 2.576 to positive 2.576. In terms of standard errors, you could say that there's a 99% chance that you take a random sample, and that random sample will be within 2.576 standard errors of the real percentage. All right, so in other words, let's write that down. There's a 99% chance that p hat, the result from the sample, is within 2.576 standard errors of the real percentage of the population, whatever that is. Okay, so let's make a little chart over here. We want confidence level and critical Z. All right, so for 99%, we just figured out it's 2.576. Okay. Now, by the way, before we go on any further, if you have a graphic calculator that doesn't do central probabilities, or like the norm inverse command on Excel or something, here's what, and all you have is, say, like a left tail probability calculation. Here's what you got to do. This is a little bit of a side note. So 99%. That leaves you with, so if you have 99% in the middle, that gives you 0.5% on either side. Right there. And so then you could do like the left tail of 0.5%, which would be 0.005. And then you can see you get the same number, but it's negative because it's on the left side. So negative 2.576. And so that's where in some statistics books, they have that subscript alpha over 2 because you take the alpha, which would be the 1%, that's 100% minus your confidence level, and then divided by 2 because there's 2 halves. So that's just a little history of where that alpha over 2 subscript comes from. But you don't have to do that if you use this website that we're using. Okay, so now let's move on. What if you want a 95% confidence level? So we had in the past said z-score is just 2, but that's not quite right. That's not totally precise. And so let's just go back to our normal curve calculator and type in 0.95 and click the in-between symbol here, the x in between negative x, positive x. Okay, this one, oh, it did it again. That's weird. Okay, 0.95. Okay, so that is 1.95996. Yes, if you round off, it's really, really close to 2, but usually people round it off to 1.96, and we'll call that good. Okay, so let's go back to our little chart. So from now on, anytime a question says find a 95% confidence interval, use 1.96. Okay, what if you want 90% confidence? What's the critical z-score for that one? And so back to here, type in 0.90 or just 0.9. I'm clicking the in-between, x in between the critical values of x. Press enter. 1.64485. Usually people just round this to 1.645. All right, so 1.645. Okay, so almost always in any homework question or a test question, those are the 3 most common critical levels that are used. Occasionally you might see something weird like, find a 97% confidence interval or 84% confidence or something. So if you see something like that, just go to the normal curve calculator, type in your central percentage, and then get whatever the critical score is. But this is something, keep this in your notes, because you'll be using these critical z-scores quite a lot in this chapter. And that's it. Thanks for watching.